Good morning children, welcome back. In the previous video we have seen about the voltmeter, the ammeter, what are the electric current and what is the charge. Okay, so in this chapter we are going to see a great scientist, that is the Ohm, who have given us a Ohm's law. Okay, where that is a Ohm's law is a relationship between potential difference across a conductor and a current flowing through it. There were two components we have seen in the earlier video, that is the potential difference and the electric current. So what relationship does it plays? So this relationship is shown in the Ohm's law. So do not write this law in your own words. Okay, you have to remember the law as it is. Okay, the current flowing through a conductor is directly proportional to the potential difference between its ends, provided its temperature remains constant. Okay, I'll break this law in parts. Okay, listen carefully where I'm giving the stress and where I'm breaking the sentence. Okay, in this way you can learn this law very carefully, very efficiently. See, the current flowing through a conductor, okay, that is I, is directly proportional to the potential difference between its ends. Okay, it is directly proportional to the potential difference between its ends, provided means what? They have given a condition that the temperature remains constant. So in this total law you have to remember only two things: the current flowing, that is I, and the potential difference V. Okay, both these are directly proportional when the temperature remains constant. Easy to remember. Okay, only two factors you have to remember in this law: the current flowing and the potential difference, and these both are directly proportional when the temperature remains constant. Okay, so the I is directly proportional to V, or V upon I is equal to constant, or V upon I is equal to R, where R is a constant called resistance for a given metallic wire at a given temperature. Okay, so verification. So we have to verify, is it directly proportional or not? Means directly proportional means what? If the current is increased, the potential difference will also increase. If potential difference goes down, the current will also go down. Okay, so this is known as directly proportional. So the verification is done now. See the cell structure given over there now. Okay, so there is the zigzag pattern is known as a resistance. The A and B are the two end points of the resistors. Then the K, that is the plug key, is given over there. The ammeter is attached, the voltmeter is attached, and the series of batteries are there. Okay, then the flow is given over there. So see, the setup of circuit as shown in the circuit diagram. First use one cell and note the current in the ammeter and the potential difference in the voltmeter across the nichrome wire AB. Repeat by using 2 cells, 3 cells, 4 cells and note the readings in the ammeter and voltmeter. Then plot a graph between the current and the potential difference. The graph will be a straight line. Okay, what did they do? Firstly, they connected only one cell. Then they measured the current and the potential difference. Then they connected two cells. Again they measured the potential difference and the current. Then they connected three cells. Then they connected four cells. Then they connected five cells. And in this way they took the readings of potential difference and the electric current. And when they plotted these readings on the current on the graph paper, they got the result that the graph was the straight line. This shows that current flowing through a conductor is directly proportional to the potential difference across its ends. The straight line indicates that the potential difference is also increasing and the current is also increasing. Okay, so that's why our Ohm's law is proved here. Okay, now what is resistance? We have constantly saying this word resistance. So resistance is a property of conductor to resist the flow of current through it. To resist means what? If such thing happens, like many electrons are just coming in a certain direction, okay, there's a lots of electrons coming, and what will happen, there are chances that the object will get heated up very fast and it can explode, correct? So to avoid this explosion, there must be a resistance, that is, there must be some watchman or a guardman to stop those electrons or to control their speed, okay. So this is done by the resistor or the resistance. The resistance is the property of conductor to resist the flow of current through it. So according to Ohm's law, resistance R is equal to V upon I, okay. That V is equal to potential difference and I is equal to electric current. So the SI unit of resistance is ohm, okay. The resistance is measured in ohm. Ohm is a name of scientist. If potential difference across the two ends of a wire is 1 volt and the current flowing through it is 1 ammeter, then the resistance R of a conductor is 1 ohm. Okay, here the 1 ohm definition is given over here. The current flowing through a resistor is inversely proportional to the resistance. What is this given? The current flowing through that is, if current is increased, the resistance will be low. If the resistor is increased, the current will be low, okay. That is why it is known as inversely proportional. You can see over here the I is at the numerator place and R is at the denominator place, okay. So that is, it is inversely proportional, okay, and I and V are directly proportional, okay. If I increases, V is also going to increase. So if resistance is doubled, then the current gets half, okay. If resistance is doubled, then the current gets halved. So what are the factors on which resistance of a conductor depends? The resistance of a conductor depends upon its length, the area of cross section and the material of the conductor. Resistance is directly proportional to the length of the conductor and inversely proportional to the area of cross section of a conductor. Means what now? Okay, there is a, what we can say, if there is a pipe given over there, okay, so the pipe is very long, okay. So what is going to happen? The more the length of the pipe, the more will be resistance, because it is directly proportional to the length. And if the pipe is very thick, okay, the area of cross section is very thick, the pipe is very big, then what it is going to happen? The resistance will be very low, okay. Why? Because it is inversely proportional to the area, okay. So that is given, the R is inversely proportional to the area of cross section. Now that is the formula given over here, that is R is equal to rho I upon A, okay. I means what? The electric current, L not I, L upon A. The L is the length of the conductor and is inversely proportional to the area of cross section, that is A, where rho is a constant of proportionality called resistivity of material, okay, resistivity of the material, and the SI unit of resistivity is ohm meter, okay, ohm meter. The rho also you can see, the rho is a constant of proportionality of resistivity. Conductors like metals and alloys have low resistivity, that is 10 raised to minus 8 to 10 raised to minus 6 ohm meter, and insulators like rubber, glass have high resistivity, okay, that is 10 raised to 12 ohm meter and 10 raised to 17 ohm meter, okay. So basically about the resistance, what you have to remember, the more the resistance, the less will be the electricity. The more the electricity, less will be the resistance, okay. That's why the conductors means what? They conduct the electricity, so there will be low resistivity. And insulators means what? They stop the electricity, so they have the high resistivity. So the resistance is the watchman, okay. The resistance is a guardman or a watchman or a soldier of that electricity, okay. So resistivity of a substances, where we have just seen this, okay. that is the conductors have the low resistivity, the insulators have the high resistivity. Substances with low resistivity are better conductors of electricity than those with the high resistivity. So here we have covered about the Ohm's law and the resistance concept. In the next video we are going to see about the resistors in the series and resistors in the parallel. Okay, thank you children.